Hi, and welcome back to this introduction to dApp development. In the previous episode, we looked at file storage, and we saw how to upload and pin files to IPFS. In this episode, we're going to discuss how to talk to a blockchain node. So we'll look at the summary of this episode. So we're first going to talk about RPC nodes or blockchain nodes in general. Then we're going to talk about the different Tezos networks, and we're going to talk about blocks and the mempool. And then finally, we're going to actually execute an on-chain operation from our dApp. So returning to this architecture diagram that we've seen many, many times before. In fact, this might be the final time that we see it. Let's have a look at where episode 8 sits on this architectural diagram. So you can see it up here at the top. So this is the episode where we're actually going to have our dApp directly talking to a blockchain node to execute an operation. So first of all, let's talk about nodes and remote procedure calls. So as the slide says, a blockchain consists of a network of nodes that we also call RPC nodes or blockchain nodes. And a node is a machine that runs a copy of the current state of the blockchain. A lot of these ideas we discussed in episode 2, so you can also refer back to that to a similar discussion to this slide. Tezos nodes or blockchain nodes or RPC nodes provide an RPC interface for us to interact with the Tezos network. And there's a link here. So if you go to the link here, you can actually see what the RPC interface is. In general, when we're developing dApps, we will use a library such as Taquito that wraps the interaction with the low-level RPC. So we're not actually necessarily needing to look at this documentation in our day-to-day work as dApp developers, but it's really useful and interesting to see how it works under the hood. And as we know, dApps can talk to nodes and submit operations, and that's what we will be doing later in this episode. Now let's talk about the different Tezos networks. And this is something that we have mentioned a couple of times before, but there are different versions of the Tezos network. The main network, the production network, the one that is actually Tezos, is also referred to as mainnet. And that is in comparison with testnet or ghostnet and various other nets that are not the proper official Tezos, but they're more just testing environments. So most of the time we have been using ghostnet. In fact, in the entirety of this course, we've been using ghostnet. But ghostnet is just a testing environment. It's not the real Tezos. And as the third bullet point says, ghostnet and mainnet are completely independent, but the protocol code is exactly the same. And the final reminder, and we'll come across this in the next episode when we actually will deploy something to mainnet, is that you do need actual Tez, which costs actual money if you want to obtain some when you're deploying to mainnet. On ghostnet, you can obtain Tez for free using a faucet, as we did earlier, but you will require proper Tez when you're deploying to mainnet or doing any interactions and operations on mainnet. And then one other thing that we should discuss is the concept of a block and memory pools. So if you remember this diagram here in the top right, that was part of our architectural diagram, this is the icon that we've used to represent an RPC node. And this part at the top was the mempool, which is the queue of operations that are coming into a node that the node is waiting to process. And then these icons here all represent smart contracts, and each operation in the mempool is applied to its relevant smart contract. And then that results in the operation being added to the new block that is created in that 15-second time interval. So let's just go through the bullet points in a little bit more detail, and also remember that you don't need to understand this in ultra high detail to be able to be a very good dApp developer, but it's useful to have a little bit of an understanding of how things are working under the hood. So every submitted operation to the node goes through pre-validation and is then put in the mempool. and then going to bullet point 3, a valid operation is picked from the mempool and inserted onto the chain in a block of operations. And this final point is where it becomes pertinent to us really as dApp developers, is that blocks are only created every 15 seconds. And it usually takes 2 blocks before a block can be considered canonical. All of which is to say that when you submit an operation to a node, firstly, it won't necessarily be executed straight away. It could be up to 15 seconds, or maybe more in some instances, but it can certainly, in normal circumstances, be up to 15 seconds before it's executed. And then even after it's put into a block, you should wait another 2 blocks, which is 30 seconds, before you can really trust that the operation being in the block is canonical, that there's no way that it can be changed or rolled back or anything like that. So the next thing that we want to do is we want to actually have our dApp execute an operation on the blockchain. And we're going to need to do a little bit of setup before we do that. So the first thing that we're going to do is we need a smart contract that our dApp can actually execute this operation on. A couple of episodes ago, we deployed or originated a couple of smart contracts onto GhostNet. For the purposes of this demonstration, I'm going to use one from the SmartPy tutorial because it's quite a simple one, and it'll mean that the interactions are relatively simple and easy to understand for this first time. So you can see here that I've gone to the smartpy.io website and I've gone to the tutorial section. And I will leave it up to you to read through this tutorial if you want to understand how this smart contract works. But during this tutorial, they create a relatively simple smart contract that allows you to mint and transfer tokens between Tezos accounts. These tokens aren't FA2 compliant, so they're not NFTs or fungible tokens in the way that you would normally find on Tezos. It's really more of just a very simple example, but for the purposes of our episode here, it's going to be great. So I've scrolled pretty much to the bottom of this tutorial page, and I used this smart contract and I deployed it on GhostNet. I did it earlier. Again, refer back to a couple of episodes ago to see how to deploy a smart contract like this. But you can find it here. So here it is on GhostNet. I deployed it earlier. And if we go into the storage, we'll see that there in the balances section of storage, there are 0 items. This means that no one has any tokens at the moment. So the first way that we're going to learn how to interact with a smart contract, interact with a node to execute an operation, is we're going to do it through a web UI. We'll use it to give a certain user a certain balance, and then we are going to update our dApp so that that dApp can then transfer some of that balance to a different user. So hopefully this will make a little bit more sense as I go along. So I'm going to go to a different tool similar to tzkt. It's called Better Call Dev, and it's really, really useful for interacting with smart contracts, especially on GhostNet. So if I copy the smart contract address and I go to Better Call Dev and I add this smart contract address in the search bar, here it is. This is Better Call Dev's view of the same smart contract that we were looking at on tzkt. So if I go to the Interact tab, it gives me these 2 entry points, mint and transfer. These are the 2 entry points on this smart contract. And I can actually, through this web UI, call these entry points. And by hitting execute here, it will actually submit the operation to a node. So let's do that now. So the first thing that we're going to do is we're going to mint, let's say, an amount of 10 to the address that we've been using for most of this dApps course, which is my GhostNet account 3. So I'm copying that address and I'm going to say that I want 10 of these tokens 10 of these DUCAT tokens, as they're called in the Smart Pipe tutorial, and I want the destination to be this address. So I'm going to hit execute and then click wallet. And what this is doing is it is asking my wallet to sign the operation to mint these tokens. I click confirm. Actually, before I click confirm, it's worth noting that this operation will cost me a very small amount of Tez, as you can see here, because all operations require a small amount of Tez. So I'll click confirm. And this operation has been submitted successfully. I can now go over to the Operations tab, and at the moment it only shows the one original operation, the origination operation, which is the creation of the smart contract. But within the next 15 seconds, we will then see a new operation appear there, which is the operation that we just submitted through the web UI. So I'm just going to hit refresh, and there it is. There was a mint operation, and we can now go back to the storage, and we should see that the address that I minted the 10 tokens to will now have a balance of 10. So let's see, storage, there we go, balances, that's my address, 10. So that is the first time that we have submitted and successfully executed an operation to a blockchain node. We did it through the Better Call Dev web UI, but we want to go one step better. We want to start doing this through our dApp itself. So let's move over to VS Code. Okay, so here we are in VS Code. This time I'm actually going to copy the code from episode 4 to be the basis for the code for episode 8. That's because the stuff that we covered in episode 5 and episode 7 isn't really necessary for what we're doing here. If you remember, in episode 5 and episode 7, we were retrieving from an indexer information about FA2 tokens that this wallet owned. That isn't really relevant, and I don't want to overcomplicate things. So I'm just going to copy this episode 4 directory, rename it to episode 8, and use that as the basis. So I will first of all just run this so that you get a reminder of exactly what we did in episode 4. npm run dev. And here we have the basis code for episode 8. I will just fix up that episode 4 to say episode 8, and then I'm going to replace sign message, which we covered in episode 4, to be actually executing an operation. So let's see. Back to VS Code, episode 8. Let's open that up, close any other tabs. So the first thing I said I was going to do was to change this to episode 8 so we don't get confused. And the second thing that I said I was going to do was I'm going to replace this sign message button with a button that instead is going to transfer, let's say, one of these DUCATs from this smart contract to a different address. We'll hard code the different address for now to keep things simple, but it should show the basic idea. So let's see. Okay, so I'm going to replace this as saying sign message. I'll replace the text to say transfer one DUCAT. And I'm going to change the name of this function to transfer DUCAT. And then up here, I'm also going to change this to, well, I can comment that one out. We don't need it anymore. Const transfer DUCAT equals, it's an async function. And then we get to the body of the function. The first thing that we need to do is to get a reference to the contract from Taquito. And the way that we can do this is const contract equals await Tezos .wallet.at, and then we need the contract address. I can grab this over here from the Better Call Dev URL. Paste it in. Great. And then the next thing that I need to do is to do the transfer itself. So I can just say await contract.methods.transfer. To be clear, this methods object will have a mint and a transfer function. So contract.methods will have a property for each of the entry points, or for all of the entry points that exist for that contract. This contract has two entry points, a mint and a transfer entry point. Therefore, there will be a mint and a transfer function available here on contract.methods. And we're going to transfer just one DUCAT, and we're going to transfer it to an address that I will put on my clipboard now. This is just a different Tezos account that I have in my Temple wallet that I'll just be using for these testing purposes. And it's literally that simple. So just to recap, we've got a reference to the contract, and then we've called the transfer function on contract.methods, and we've given it the two parameters that we want to transfer, one DUCAT, and this is the address that we're going to transfer it to. I mustn't forget that I need to add .send at the end. I'm also going to add a console log just so that we know when it's done, because we haven't got any UI that is indicating that the click has happened. So console.log transfer of one DUCAT completed. So now let's give that a go. Got my console open, which I can just clear, and click transfer one DUCAT. And again, as with when we did it through Better Call Dev, it has triggered my wallet to ask me to sign the operation. I will sign the operation. And now at the bottom here, you can see transfer of one DUCAT completed. So now let's go back over to Better Call Dev. And firstly, let's wait for the transfer operation to come in. We need to wait up to 15 seconds. I reckon I can probably hit refresh now and it'll probably be there. Let's have a look. There it is. The transfer is there. And I'm now going to go to the contract storage. And as we hoped, the balance of the original address has gone from 10 to 9, and the balance of the new address has gone up to 1. Excellent. So there we've done it. We've done our first ever operation from our dApp to a blockchain node. So all that's left to say is thank you so much for listening to episode 8. We've got 2 more episodes to go, episodes 9 and 10, and I look forward to seeing you then.